So guys, in the last class, we discussed about the nature of the roots. If we have, we said that if we have a quadratic equation in the form of ax square plus bx plus c, and if you want to identify the nature of the roots, we use the concept of discriminant, b square minus 4ac. The value of b square minus 4ac can either be positive, meaning greater than 0, less than 0, or equal to 0. When the value of the discriminant for a particular quadratic equation, okay, for quadratic equation comes out to be greater than 0, we said that the nature of roots, nature of the roots were real and distinct. If the value of the discriminant was equal to 0, we said that the nature of the roots are real and equal. And when the discriminant was less than 0, we said okay, no real roots are going to be there. What was the meaning of uh, real and distinct roots? The meaning of real and distinct roots was that there are going to be two different roots when you are going to set this equation to 0. So if I were to solve this equation, ax square plus bx plus c equal to 0, I'm going to get two values of x. These are the two different roots. If the value, for this equation, if the discriminant came out to be 0, we said that the nature of the roots are going to be real and equal. That meant that the curve is going to be tangent to the x-axis. The x-axis is going to be tangent to the curve. Okay. So that means that the curve is only going to intersect the x-axis at only one point. And when we have no real roots, that means that the curve is either entirely above the x-axis or below the x-axis, which further means that there is no intersection point between the x-axis and the curve. So there are no roots. Okay, that was the thing that we discussed in the last class. Now, in today's class, I'm going to
So
extend.
in exam,
Yes.
we just need to write if it's real and distinct or real and equal and no real roots. That's it.
Yeah, so I'll tell you what questions or what type of questions are going to be coming in exam. But right now, if I ask you whether an equation will have real and distinct roots, you are going to apply b square minus 4ac on this particular equation, and you're going to calculate the value. Okay, if the value of this equation is great, if the value of the discriminant is greater than 0, you are going to say that the roots are real and distinct, which means that if you were to solve this equation, you will have two different roots, like we did over here. So if I know that the discriminant of this equation is positive, so when I'm going to solve this equation, I'm going to get two different roots. When the discriminant is equal to 0, that means that I'm going to have real and equal root. That's why you were only getting one value. That means that the x-axis is basically tangent to the curve. And when the value of the discriminant is less than 0, let's say in this particular example, then it means that the equation will have no real roots, and that's why we were not able to solve the equation for the values of x, which means that since there is no x-intercept, the curve is entirely above the x-axis. It's not touching the x-axis. Okay. Now, if I extend the similar concept to the intersection of a line and a quadratic curve, for example, a line and a curve can intersect at two different points. A line can be a tangent to the curve, meaning intersecting the curve at only one point, or the line may not intersect the line may not intersect the curve at all. Okay, the line may not intersect the curve at all. Okay, so these are the three cases. Now, if I give you an equation, if I give you an equation of a line, let's say y equals to 2x plus 3, and I give you an equation of a curve y equals to x squared, how would you how would you guys find the intersection point? How do I find the intersection point if the equation of a line and the curve are given to me? I have the equation of a line, I have the equation of a curve. My question is that if I ask you to find these intersection point, what are you going to do? Yes, Abdurrahman, we are going to solve these two equations simultaneously. Very good. So if I solve these two equations simultaneously, which means that using equation number one, I'm going to make a variable a subject. So let's say y is equal to 2x plus 3. And I'm going to substitute y in equation 2. So y is equal to x square. Y value is 2x plus 3 equals to x square. Okay. So basically you are trying to say that you are going to equate the two y's. Y over here is 2x plus 3 and y over here is x square. So you have basically equated the equation of a line with the equation of the curve. And then when you simplify this equation, it's going to be x square. Okay, if I bring all these terms to the right hand side, it's going to be x square minus 2x minus 3 equals to 0. Isn't it? Yes or no? Will we get this equation
Yes, sir.
after simplifying this? Now, this is my quadratic equation, right? If I'm going to solve this quadratic equation, so I'm going to be getting the following roots. I'm getting 3 and minus 1. This equation x square minus 2x minus 3 equals to 0. If you solve for the values of x, the values of x are basically the x-intercepts, okay? Or the roots or the solutions. What can you say about the nature of the solutions? The solutions are real and distinct, right? You're getting two different values of x. So the solutions are real and distinct. The solutions for this equation are real and distinct. Okay. Now these solutions of this equation are basically the intersection point, the x coordinate of the intersection point. So if we have to look at the nature of the intersection point, whether the line is going to intersect the curve at 1 point or 2 point or will not intersect at all, the first thing that you're going to do is you're going to equate the equation of a line and equation of a curve, and then try to rearrange it until it is in the quadratic form. Now, when I solve this equation, I'm going to get two values, right? These two values are indication that the line is intersecting the curve at 2 points. Okay. So can you guys confirm that if I will calculate the discriminant, if I am going to calculate the discriminant of this equation, what will it be? What is going to be the discriminant of this equation? Is it positive? Is it negative? Or is it equal to 0?
Sir, just give me a minute.
Joel, are you getting 16?
Sir, it's 16.
Right.
Yes, sir.
So that means that the discriminant is greater than 0. If the discriminant is greater than 0, what can you say about the nature of the solution, nature of the roots of this equation? Real and distinct. Real and distinct roots. Okay. If the roots are real and distinct, that means that the line is going to intersect the curve at 2 points. Are we getting the idea?
Sir, you mean that if we use also simultaneous equation, we'll get we must use b square minus 4ac to find if it's real and distinct.
Yeah. So if I have the equation of a curve and equation of a line, so I know that there are three possibilities. The first possibility is that the line is going to intersect the curve at 2 points, or the line is tangent to the curve, or the line and the curve do not intersect at all. To find the point of intersection, I will solve these two equations simultaneously. So when you solve these two equations simultaneously, this is the resulting quadratic equation that you get. If you simplify these terms, you're going to get x squared minus 2x minus 3. Now, if the question says find me the intersection point, you're going to solve for these values and you are going to get x as minus 1 and x as 3. And then you can find the y coordinate. So you can get these 2 points, point of intersection. But let's say if the question is not asking you to find the intersection point, and I just ask you to find the nature of the intersection point, like whether the line is going to intersect the curve at two different points or one point or will not intersect at all. So you can use the concept of discriminant. If the discriminant comes out to be greater than 0, if the discriminant comes out to be greater than 0, then your line is going to intersect the curve at more than 1 point, that is 2 points. And if the discriminant comes out to be less than 0, that means that the line and the curve are not going to intersect at all. If the discriminant comes out to be equal to 0, that means that the line is going to be tangent to the curve. Are we clear with this concept? So again, it depends on the value of b squared minus 4ac. But when we have solved the equation of a line and a curve simultaneously and reduce the equation into the quadratic form, then you can decide if the discriminant, you can decide on the basis of discriminant value. If the discriminant value is greater than 0, that is the case. If it's equal to 0, then this is the case. If it is less than 0, then the line and the curve are not intersecting at all. Are we good till here?
Yes, sir.
Okay. So if I want to summarize this, can I say that the discriminant is, if the discriminant is greater than 0, then the roots are real and distinct?
Yes, sir.
And what can I say about the intersection points of line and curve?
There
2
are
points
points.
of intersection. Okay, if the discriminant is equal to 0, then that means that for this quadratic equation, you will have real and equal roots. And what can I say about the line and the curve? 1 point of intersection. Okay, that this is the case where 1 point of intersection is there, which means that the line is going to be tangent to the curve. Okay, line is tangent to the curve. And when the discriminant is less than 0, we have no real roots. This means that the line and the curve are not going to intersect, no intersection point. Is this making sense now?
Yes, sir.
Okay. So I want you to do this question with me. Write down the question. Let me know when you have done writing it down. Okay, now the question says that find the value of k for which this equation, this is a line equation, right? It's in the form of y equals to mx plus c, is tangent to the curve y equals to x squared plus 5x plus 2. So the first thing that, understand the question. Question says what must be the value of k over here so that the line is basically tangent to the curve. Can you guys quickly recall, if we want the line to be tangent to the curve, what do we said about the discriminant? What is,
X
Equals to 0.
yes, b square minus 4ac must be equal to 0. So how do you begin this question? You have the equation of the curve, you have the equation of a line. To get to the solution, the intersection point, I will have to equate the equation of a line with the equation of a curve. So please do that. Equate the equation of a line with equation of the curve. Or as to say, solve them simultaneously. So equation of a line is x plus k. Equation of the curve is x square plus 5x plus 2, isn't it? Then in the next step, you're going to rearrange the equation in the quadratic form. So I can bring these terms to the other side. It's going to be x squared plus 5x plus 2 minus x minus k equals to 0. You rearrange the terms, x squared plus 5x and minus x is plus 4x plus 2 minus k equals to 0. Are you with me till here?
Yes, sir.
Sure. Are there any
Yes,
questions?
sir.
Now this is my quadratic equation. So what can you, if we want the line to be tangent to the curve, what can we say about the discriminant of this equation?
That y is greater than.
If we want the line to be tangent to the curve, what can we say about the discriminant of this equation? We did agree that the
Y is equals to b square minus 4ac.
no, not y equals to b square minus 4ac is going to be equal to 0. So, so I'll use the concept of discriminant now to find the value of k. I'm going to say that since line is going to be the tangent to the curve, then the discriminant of this equation must be set equal to 0 because line is tangent to the curve. Line is tangent to the curve. Okay, now what is the value of b over here? Can anyone tell me?
4x
B value is 4. A value
plus
is
4.
1.
1.
C value is
2 minus 2.
2 minus k. So B value is 4. A value is 1 and C value is 2 minus k equals to 0. You get this equation, please solve it for the value of k. Tell me what is the value of k going to be?
Sir, 4.
Solve again. 16 minus 8 plus 4k. 4k equals to minus 8. So k equals to minus 2. K value is minus 2.
Oh, sir, I didn't multiply 4 by 2.
Okay. Now, what is the
Yes.
meaning of this? If my k value is going to be negative, so we are done with the working of the question. Now I'm just explaining it to you in detail. If the value of k is minus 2, then your equation of the line is going to be, what is the equation of my line going to be? If the value of k is minus 2, would you agree that the equation of the line is going to be y equals to x minus 2? And equation of the curve is going to be x squared plus 5x plus 2. If I were to solve these two equations simultaneously or draw the graph, I would see that this line is going to be the tangent to the curve. Let me show you. So what was the equation of a line? Y equals to x minus 2, right? And what
Yes,
was
sir.
the equation of the curve? Y equals to
Y is equals to x square plus 5x
x square plus
plus 5
5x
minus 2.
minus 2. Minus 2? No, no.
Plus 2 plus 2.
Plus 2.
Yes.
9. Plus 2. Okay. Okay. Now do you see my graph? For this value of k, the line is going to become tangent to my curve. Do you see that the line is intersecting the curve at only one point?
Yes, sir.
This is the point where the line is tangent. Okay. So it's just one point where the line is touching the curve, and so we say that the line becomes the tangent to the curve. So for what value of k was that possible? When the value of k in the question turned out to be K value turned out to be -2. Abdul Rahman, do you understand this?
Yes, sir. Yes, sir.
Okay. Okay. Find the set of values. Solve this. Find the set of values of K for which the line does not intersect the curve. Find the set of values of K for which the line does not intersect the curve. So we want our line not to intersect the curve. So what can we say about the number of solutions?
Smaller than 0.
Yeah, so we are going to say that there are no points of intersection. And when was that possible? When the discriminant of the quadratic equation is going to be less than 0. So I already
Yes.
know this, that it is not intersecting. So I can use this concept of discriminant. The first step that I'm going to do is I'm going to equate the two equations simultaneously. So from the equation of the line, 2x plus y equals to k. What is y going to be equal to? K minus 2x. From the equation of the curve, xy equals to 8, y is equals to 8 upon x, right? Now you can equate the equation of a line with the equation of the curve, and you're going to get a quadratic equation. So when you multiply this, you get kx minus 2x square equals to 8. 2x square minus kx plus 8 equals to 0. Okay. Now we need to find the
Sir,
set.
-8.
We need to find the set of values of k for which this equation must have no real roots. Why no real roots? Because we don't want the curve and the line to intersect. So when we solve these two equations simultaneously, the resulting equation must have no real roots. Okay. So now we are going to apply the concept of discriminant. We know that this equation should not have any real roots because we do not want any point of intersection. So the discriminant of this equation must be less than 0. Okay, now what is the value of b in the question? What is the value of b in the question?
Sir, B, K.
B is minus k. The value of a in the question
Yes.
is,
2
and the value of c in the question is
plus 8.
8.
8.
So b square minus 4ac less than 0. B value is minus k. A value is 2. C value is 8 less than 0. K square minus 64 less than 0. Now, guys, this becomes your quadratic inequality. So the two, it's k square minus 8 square, which is equal to k plus 8 times k minus 8. Remember,
Yes.
these are the factors. So what is going to be the range of values of k? Guys, come on, this is quadratic inequality. We have done this in the previous classes. What are the critical values of the Riemann? What are the critical values of k? If this is my quadratic expression, what are the critical values going to be? K equals to minus 8 and k equals to plus 8,
Plus 8.
right? So this means one
The
value,
curve will intersect at 2 points.
no, we are not talking about these two curves. I'm just talking about this equation. Okay. When it was less than 0, what would be the required range of k?
Yes, sir.
What would be the required range of k? Since it is less than 0, so the required region is below the x-axis. So k value should be greater than minus 8 and less than 8, remember?
Less than 8. Yes, yes, sir.
So that's the idea. Let me know if you have any questions still here.
No, sir.
You understand all the concepts?
Yes, sir. Just need revision.
Yes, sir.
You need to write it down? Okay.
Sir, I wrote it down already.
Okay. So let's practice some questions. Just a second. Okay. Can you try doing these questions? I want first you try question number 6 and then try question number 9 as well. Question 6 and question 9.
Sir, we don't need to write the question, yeah?
No, don't write the question or just take a picture of it.